welcome to virtualbrigade.com. In my previous video I have shown you how to create the logical switches and how to connect the vCenter server virtual machines to the logical switches, and I have also explained you how to connect your virtual machines running on the KVM environment to the logical switches. In this particular video I'll explain what is switching profile and what are the different switching profiles that we have in the NSX manager and how to create the switching profiles. With that, let's get started. In order to create the switching profiles, you can log into the NSX manager as an admin, and from the NSX manager homepage you can click on switching, and then you can go to the switching profiles to see the number of switching profiles that we have in the NSX manager by default. So you can see we have a few switching profiles available, and all the switching profiles will have a default ID associated with it. Each switching profile that we create will have an identifier, and then the type. There are 6 to 7 switching profile types. One switching profile is the IP discovering, the second one is the MAC management, and the third one is the port mirroring, and the fourth one is the quality of service, and the fifth one is spoof guard, sixth one is the switch security. So 1, 2, 3, 4, 5, 6. So we have 6 different types of switching profiles that the administrator can create, and these are defined by the system, which are available as soon as you deploy the NSX manager, and the assignment to which logical switch or the logical port that these switching profiles are belong to. So what is a switching profile? So basically a switching profile is the configuration that you want to apply to the logical switch or to the logical port. So the NSX manager supports several different types of switching profiles. As I have mentioned, we have 6 different types of switching profiles available in the NSX manager. So the first one is the IP discovering, the second one is the MAC management, port mirroring, quality of service, spoof guard, and switching security. So you cannot these are the default switching profiles. You cannot make any changes to the default switching profile, or you cannot delete the default switching profile. If I select the default switching profiles, the edit and the delete options are grayed out. So if you want to create a new switching profile, you can click on the add button, and then you can select which type of switching profile that you want to create. Let's say if you want to mirror the packet to a different port, you can click on the add new switching profile, and then you can specify the name, the direction, the description, the packet truncation. If you want to truncate the packets of certain size, you can truncate that, and you can enter the key and the destination you can specify, and then you can click on save to create a new switching profile. Once you create the switching profile, you can assign the switching profile to the logical switch or to the logical port. So now we have seen what are the default switching profile, what is a switching profile, and where is the switching profile applied to. So these are the 6 different types of switching profiles that you can create, and you can assign it to a logical switch or to the logical port. In order to create the switching profile, you simply log into the NSX manager. From the NSX manager homepage, you can click on switching, and then you can go to the switching profiles to create the switching profile. So I'll go ahead and explain each of these switching profiles. So let's go ahead and get started with the QoS. So the QoS switching profile, so the quality of service switching profile basically provides the high quality and the dedicated network performance for preferred traffic, which basically requires a high bandwidth. The quality of service mechanism does this by prioritizing the sufficient bandwidth by controlling the latency and jitter, and it will also reduces the data loss for preferred packets even when there is a network congestion. This is pretty much similar to what we have in vSphere, wherein you can create the network resources or the network IO control so that the virtual machines will get the highest priority when there is a network congestion. So this level of network service is provided by using the existing network resources efficiently. In this particular release, we will be using the shaping and the traffic marking, so which provided by your COS, which is class of service, and the second one is the differentiated services code point. So the layer 2 class of service allows you to specify the priority for the data packets when the traffic is buffered in the logical switch due to the network congestion. And the layer 2 differentiated service code point, which is the DSCP, basically detects the packets based on the DSCP value. So COS is always applied to the data packet irrespective of the trusted mode. So let me go ahead and create the QoS so that I can show you what you can specify in the QoS profile. So you enter the name, you enter the description, and the DSCP value, the differentiated services code point. So you can configure the DSCP in two different modes. One is your trusted and the second one is untrusted mode. So the NSX-T trusts the DSCP settings applied by a virtual machine are modifying and setting the DSCP value at the logical switch level. In case the DSCP value is propagated to the outer IP header of the encapsulated frames, this enables the external physical network to prioritize the traffic based on the DSCP setting on the external header. So when the DSCP is in the trusted mode, the DSCP value is copied from the inner header. When it is configured in a untrusted mode, the DSCP value is not preserved in the inner header. So the DSCP settings work only on the tunnel traffic. These settings do not apply to traffic inside the same hypervisor. So I can create, let me go ahead and create the the quality of service. Let's say I am going to use the test QoS profile. So test QoS profile, which is the description for my QoS profile. I will use the DSCP mode as trusted, and you have the class of service. We have the class of service all the way from 0 to 7, I think. Yeah, 7. So you can put the class of service from 0 to 7, and then you can also specify the type. You have the ingress, broadcast, and egress. So once you specify this, you can click on save. This particular wizard will save the QoS test QoS profile. If I want to assign the switching profile to my logical switch, I can select the logical switch, go to the edit settings, and then I'll go to the switching profiles tab. From the switching profile tabs, I can go to the QoS. From the QoS switching profiles, I can now see the test QoS profile. I'll select this profile and then click on save, so that the QoS profile is applied to the app tier logical switch. So this is how you can create the QoS switching profile, and you can assign the switching profile to the logical switch. Let me go ahead and cancel this out. I don't want it to apply this QoS switching profile to my logical switch. So this is very helpful when there is a network congestion for the network resources. You can always prioritize the virtual machine workload so that all the virtual machines running on that particular logical switch will be given the highest priority. So let's go ahead and discuss about the port mirroring switching profile. So in order to create the port mirroring switching profile, I'll go to the switching profile tab. From the switching profile tab, I will click on add, and then I'll select port mirroring. From the port mirroring, once I click on the new port mirroring profile, I'll enter the name test port mirroring profile. And then you can specify the direction of your packets. So the logical port mirroring, which basically replicates and redirects all the traffic coming in or going out of a logical switch as connected to the virtual machine's virtual interface. The mirror traffic is encapsulated with a Geneva routing encapsulation tunnel to a collector, so that all the original packet information is preserved while it is traversing through the network to a remote destination. So it is typically used for the purposes of troubleshooting, to analyze the traffic, to detect the intrusion, and debug and diagnose the errors on a network. And the port mirroring switching profile will also be used for the compliance and the monitoring purposes. So to forward all the monitored traffic to a network appliance for analysis and the remediation. So when you think of the port mirroring in the physical environment, physical port mirroring, logical port mirroring ensures that all of the VM network traffic is captured. So if you implement the port mirroring only in the physical network, some of the virtual machine traffic will be failed to be mirrored. So this happens because the communication between the virtual machines sometimes may be running on the same host, which will never enter the physical network. And so the port mirroring does not actually get mirrored. While logical port mirroring, with the logical port mirroring, you can continue to mirror the VM traffic even when the virtual machine is migrated from one ESXi host to another ESXi host, or if you have a KVM host, if you have powered on the KVM virtual machine onto a different hypervisor. The port mirroring process is similar for both VM ports in the NSX-T domain and ports of physical application. You can forward the traffic captured by a workload connected to the logical network and mirror the traffic to a collector. So the IP address should be reachable from the guest IP address on which the virtual machine is hosted. So this process is also true for the physical applications connected to the gateway node. So in order to create the switching profile, you can click on add from the switching profiles tab, and then you can click on add a port mirroring profile. You need to enter the name of the switching profile, and you need to enter the description, which is optional, and the direction. You can select an option from the drop down menu to use this source for ingress, egress, and bidirectional. So if I click on here, the direction can be ingress or egress or bidirectional. Ingress is the outbound network traffic from the virtual machine to the logical network. Egress is the inbound network traffic from the logical network to the virtual machine. So bidirectional is the two-way of traffic from the virtual machine to the logical network and from the logical network to the virtual machine. So bidirectional is the default direction, and the packet truncation, so which is an optional. The range can be anything from 60 to 65535, which is the maximum packet that you can truncate. And the key enters enter a random 32-bit value to identify the mirror packet from the logical port. So you can enter, and this key value is copied to the key field in the GRE header of each mirror packet, and you can enter the destination, enter the destination ID of the collector for the mirroring session. So you need to enter the ID of your destination ID of your external collector. So the destination IP address can only be IPv4 address within the network, or a remote IPv4 address which is not managed by your NSX-T. You can add up to 3 destination IP addresses which are separated by comma. So once you enter the information, you can click on save, and as I said, you can apply it by going to the switches tab and select the switch and then click on edit, and then you can go to the switching profile and you can select the port mirroring, and you can select the custom switching profile that you have created, and then click on save. So the switching profile is enforced on this logical switch. So that is about how to create the port mirroring switching profile. So let me go ahead and discuss about the IP discovery switching profile. So in order to create the IP discovery switching profile, you can click on add, and then you can click on IP discovery. So the IP discovery basically about learning the IP address and the MAC address of a virtual machine. So the IP discovery basically uses the DHCP snooping and the ARP snooping, and also the VMware tools. If you have the vSphere environments with the virtual machines running, and you have the VMware tools installed, so the VMware tools method is only applicable for the vSphere environment. There are three different methods that you can learn the IP addresses and the MAC addresses of a virtual machine. First method is the DHCP snooping, and the second method is your ARP snooping, and the third method is only applicable for the vSphere environment, which is your VMware tools. After the MAC address and the IP address are learned, the entries are shared. So once the virtual machine is powered on and it sends the first packet, the NSX controller is being informed about the location of the virtual machine, and also the NSX controllers are being informed about the IP address and the MAC address of the virtual machine, and the NSX controller's responsibility is to share the information that is being learned on the hypervisor to the other transport nodes. So the NSX controller is going to once the virtual machine is powered on, the TEP device on the ESXi host learns the IP address and the MAC address of the virtual machine, and it will send that information to the NSX controller. The NSX controller is then send it to the all the transport nodes that are configured in that transport zone. So the DHCP snooping inspects the DHCP packets that are being exchanged between the VM's DHCP client and the DHCP server to learn the VM's IP address and the MAC addresses. So the ARP snooping inspects the outgoing ARPs and GA ARPs of the virtual machine to learn the MAC address and the IP addresses. And VMware tools, as I said, the VMware tools is a software that runs on the virtual machine in the ESXi host in the ESXi environment, and it can provide the VM's configuration information which is available in the virtual machine configuration file, including your MAC address and the IP address. This IP discovery method, this VMware tools method, is only available for the VMs running on the ESXi host. So to create the new IP discovery profile, you enter the name, you enter the description, and if you want to enable the ARP snooping, you can toggle the button to enable, and you have the upper limit of ARP binding limit, and then DHCP snooping. So the packets which are being exchanged from the DHCP client and the DHCP server, and the VMware tools method is for the virtual machines running on the ESXi hypervisor. And then you can click on the save button so that the new switching profile is created. And once you create the switching profile, you go to the logical switch, and you can click on the edit button, and then you go to the switching profile tab, and you can make the changes to the default switching profile to the new custom switching profile that we have created. So the next is the spoof guard switching profile. So in order to create, what is a spoof guard profile? So the spoof guard profile helps prevent a form of a malicious attack called web spoofing or the phishing. Once the spoof guard policy is enabled, it is going to block the traffic determined to be spoofed. A spoof guard basically is a tool that is designed to prevent virtual machines in your environment from sending traffic with an IP address which is not authorized to end the traffic from. So when you create the switching new spoof guard profile, so the spoof guard profile basically uses the port binding. So which means on a given logical port, the IP addresses or the MAC addresses are learned. When the attacker make the changes to the virtual machine, or when the attacker has access to the virtual machine and tries to enter into the network environment by changing the IP address or the MAC address. If the virtual machine's MAC address is different from the port that is given, then the port binding profile, which is enforced through the spoof guard, will be disabling or stopping all the traffic. So what are the advantages? What are the several reasons spoof guard might be used? If it prevents a rogue virtual machine from assuming the IP address of an existing VM. It ensures the IP address of a virtual machine cannot be altered without any intervention. It's preferably that the virtual machines cannot alter their IP addresses without proper change control review. So when if you want to make any changes to the virtual machine, so for any reason, you can update your port binding, so that you go to the port binding and then you change the port binding to a new IP address or to a new logical to a new MAC address. So this is about the spoof guard switching profile. So let me go ahead and create the port address binding. So in order to create the port address binding, so let me go to the switches, click on the switch and then go to ports. To create the port address binding in NSX-T, you log into the NSX manager, click on switching and then go to ports tab. From the ports tab, you click the logical port. You can click, let's go ahead and select this particular port. And then go to the summary tab where you can see the address bindings. So we have not configured any port address binding on this particular logical port. If I want to add the manual binding, so on this particular given port, I want to enter the MAC address of the virtual machine and the MAC IP address of the VM, so that I can create the port address binding. If there is any change in the IP address or if there is any change in the MAC address, then the virtual machines would be denied access to the environment. So with this, only on this particular given logical port, the virtual machine will be able to communicate since we have created the port address binding. So when I am specifying the port address binding, I'll specify the MAC address and the IP address of a VM. And then I'll also specify the VLAN ID of the VM. Let's go to the switching profile and I'll show you what is the MAC management switching profile. So the MAC management switching profile supports two functionalities. One is your MAC change, and the second one is the MAC learning. So the MAC management switching profile has two functionality. One is the MAC change and the second one is the MAC learning. So the MAC address change feature allows a virtual machine to change its MAC address. A VM connected to a port can run an administrative command to change the MAC address of its VNIC and can still send and receive the traffic on that VNIC. So this particular feature is supported only on the ESXi and not on the KVM host. So this particular property is disabled by default. As you can see, as soon as we have clicked on new MAC management profile, this particular policy is disabled. So the MAC learning policy provides the network connectivity to deployments where multiple MAC addresses are behind one virtual network interface. So let's say you have the ESXi running in the nested environment. So I have the physical ESXi box. On the physical ESXi box, we have deployed a nested ESXi virtual machine which is connected to a virtual network interface to a virtual switch. And on the nested ESXi box, you might have multiple virtual machines running on it. So by default, the virtual machines connectivity running on the nested ESXi box is disabled for those VMs. In order to enable the connectivity to the virtual machines running in the nested ESXi environment, you can enable the MAC learning policy, and you can apply it to a logical switch, and then you can connect this nested ESXi virtual machine to that logical switch, so that you can enable the connectivity to the virtual machines running on the nested ESXi box. So this is about the MAC management switching profile. So we have discussed about the switching profiles. So we discussed about what is switching profile, how to create the switching profile, and what are the different types of switching profiles that we have, and what are the default switching profiles, and how to assign the switching profile to the logical switch. And we have discussed about all the different types of switching profiles that we can create. In my next video, I'll take you through the logical routing, where I will discuss what are the different types of logical routers we have, how to create the logical routers, and how do you connect your logical switches to the logical routers. I thank you for watching, and please do subscribe to my channel.